Alright, so in this video, we are going to review linear pairs of vertical angles. Those are two foundational angle relationships for geometry. They're going to help us out a lot when we get to the bulk of Chapter 7, which deals with angle relationships between parallel lines. So, if you recall, if two adjacent angles form a line, so something like this, we call this angle 1 and angle 2. Then the two angles are supplementary angles. And if angle 1 and angle 2 are adjacent angles that form a line, then angle 1 and angle 2 are supplementary angles. So different ways of just reading that. In this case, angle 1 and angle 2 are adjacent angles. They share this side. That makes them adjacent. And they form a line. So they are supplementary. So we can say that the measurement of angle 1 plus the measurement of equals 180 degrees. And that exists no matter how these two angles form that line or their relationship to each other. They're going to add up to 180 degrees. Another angle relationship we looked at were vertical angles. If two lines intersect, then the non-adjacent angles formed at their intersection are congruent. So let's look at that. Let's get two lines that intersect. Right, so we got lines P and Q. They intersect, or line segments P and Q. Then we have these four angles. So we got angle 1, angle 2, angle 3, and angle 4. And again, it doesn't matter which one, how we label these angles. What matters is the relationship, their physical relationship to each other. Okay, it's not about the numerical pairings or anything like that. But the non-adjacent angles formed at each intersection would be angle 2 and angle 4, or angle 1 and angle 3. These would be our non-adjacent angles. And so we can say that the measurement of angle 1 is equal to angle 3. Or rather, before that, we can state that angle 1 is congruent to angle 3, which implies that their measurements are equal. Okay, so that relationship exists anytime two line segments or line segments intersect each other. We can also say similar thing or same thing about angles 2 and 4. They are congruent to each other because they are vertical angles. Okay, so up here, I guess I don't know, angle 2 and 4 doesn't really matter. You can put 1 and 3. It's also worth noting that, looking at this diagram, angle 1 and 2 are a linear pair. So angle 1 and 2 add together and equal 180. Well, 2 and 3 are a linear pair. They form line Q. So 2 plus 3 also add together and equal 180. 3 and 4 also add together and equal 180. And we're going to see this setup again when we get to transversals, okay? Because a transversal is just a line that intersects two lines. So we'll look at that, but let's just go ahead and review setting up some equations and solving those equations. So if you need a reminder on linear pairs of vertical angles and supplementary angles and what those equations look like, pay attention to what's about to happen. If you don't need a review for it, you might want to skip ahead maybe a couple minutes. But here we go. Linear pairs. It says use the diagram to identify two example pairs of each type of angle relationship listed below. Write an equation that represents each angle relationship. So I'm going to identify a pair, create the equation, and then for the second line, you can identify a pair and an equation. So a linear pair for me, I know I used 1 and 2 before, so I'm going to switch it up and say 5 and 7. Angle 5 here and angle 7 here. They form this line. And So they are a linear pair. So angle 5 and 7 are a linear pair. So an equation we can write knowing that they are a linear pair is that the measurement of angle 5 plus the measurement of angle 7 is equal to 180 degrees. So two angles that form a line. That's what you're looking for when coming up with a linear pair. So go ahead and take a moment and identify another linear pair. Alright, so here we go. So we're looking for two angles that form a line. So another two angles that form a line would be angles 3 and 4. Angles 2 and 4. There are many examples that you could pick from here. So, you know, what I'm about to write may not be what you wrote, but as long as those two angles form a line, you're in a good shape. Alright, so there's a relationship. Angle 2 and angle 4 add together and equal 180 degrees. Vertical angles. So again, we're looking for those non-adjacent angles. Those are those angles that are like diagonal from each other, if you will. That would probably be a better name for it, but we work with what we got. So here we go. Vertical angles. An example of that would be 2 and 3. Now vertical angles are congruent, so an equation we can write would be an equation that says that their measurements are equal. So here we go. Alright, see, short, sweet, simple. Find another pair of vertical angles. Alright, so another pair of vertical angles would be angle 5 and angle 8. Or angle 6 and angle 7. Or if you listed angles 1 and angle 4, you will have successfully identified vertical angles. Alright, so now moving on to the term supplementary. Okay, if you recall supplementary angles, we started off this lesson with a linear pair. Two angles that form a line, they are supplementary. Okay, we're not always going to say they add together and equal 180 degrees. Outright, at least anyways. Often they'll tell you, hey, these are supplementary. They want you to know that. That means that they add together and equal 180 degrees. So, supplementary angles are angles that form a line, so that's what I look for. So angle 6 and angle 8 form a line. So angle 6 and angle 8. So an equation I could write would be angle 6, the measurement of angle 6 plus the measurement of angle 8 equals 180 degrees. Okay, I'm challenging you. Don't just reuse this. That would be easy. But, you know, step outside of the box, okay? 1 and 3. Angle 1 and angle 3 form a line. So the measurement of angle 1 plus the measurement of angle 3 equal 180 degrees. Okay. So that's the basic understanding of what's going on. Again, that's level 1, understanding the vocabulary. Level 2, we're going to do some basic applications with that. Here we have two lines that intersect each other, and we're asked to find some angle measures. They tell us that the measurement of angle 1 is 129 degrees. We need to find the measurement of angles 2, 3, and 4, and to justify the relationships. So they gave me angle 1. I'm going to start with this. This is angle 1, 129 degrees. And I'm just going to go in order. They say angle 2, angle 3, angle 4. You could probably identify the measurement of angle 3 by now. So let's just go ahead and dive into this. It's not that deep. The measurement of angle 1 is supplementary to the measurement of angle 2. Okay? So here's an equation we could write. Oops, not 129. 180 degrees. All right, there's a correct equation we could write, should I say? So now we could substitute some values in place of the measurement of angle 1. We know that's 129 degrees. So that's substitution. That's a better substitution. Showing that step. And then we can subtract 129 from both sides of the equation. And conclude that the measurement of angle 2 is 51 degrees. Okay. So that was our linear pair postulate, which allowed us to state that these two angles are supplementary. Now from there, we can easily find the other two angle measures. The measurement of angle 3 is equal to the measurement of angle 4. That's our vertical angles theorem. So then the measurement of angle 3 is not equal to angle 4. Sorry about that there, autopilot. It's equal to measurement of angle 1. The measurement of angle 3 is equal to the measurement of angle 1 by the vertical angles theorem. And so the measurement of angle 3 equals 129 degrees. And for similar reasons, we can state that the measurement of angle 4 is equal to the measurement of angle 2. So the measurement of angle 4 is equal to 51 degrees. Okay. So those are some basic applications of those relationships. And the next examples, we're going to look at some more detailed, some more in-depth or intermediate examples. We're going to actually use some algebra. So if it's the algebra that you're struggling with, you might feel like you're very good on this content. But if it's the algebra aspect of solving equations, then pay attention to what I'm going to do in those problems coming up. So if you turn the page, you'll see number 2 and 3. So let's work out these problems. Number 2 says use the diagram to create an equation, then use the equation to solve for x. Alright, so looking at this diagram, there are two angles that we have to work with. We can call this angle 1, we can call this angle 2. And angle 1 and angle 2 are vertical angles. Okay, we have our two lines intersecting. They're diagonal from each other. Okay, non-adjacent, however you want to define that. So we know that the measurement of angle 1 plus the measurement of angle, we know that the measurement of angle 1 is equal to the measurement of angle 2. So we can substitute those values in and say 118 degrees is equal to 13x plus 66. And then we just use inverse operations to solve for x. So go ahead and solve for x and verify that you did that correctly. Alright, so here we go. I'm going to subtract 66 from both sides. I see that plus sign, and that's my constant term, so I'm going to eliminate that from the right side, so I'm going to also subtract it from the left side. And 118 minus 66 is 52. And on the right side, we're left with 13x. And then finally, we divide both sides by 13. When we get that x is equal to 4, or literally 4 is equal to x. Okay, so we solve that equation. For number 3, We use the diagram to create the equations, the same directions. Except now we got to solve for x and z. So I look at my diagram and I say, okay, well, I have an expression with x here, and I have another expression with x. How do these two angle measures relate to each other? Well, one angle is over here, they're adjacent angles. They form a line. So, you know, I can say that this is angle 1, and this is angle 2, and that the measurement of angle 1 plus the measurement of angle 2 is equal to 180 degrees. And then we can use substitution. I don't need the parentheses. I could go ahead and drop that. 13x minus 42. Sorry, that's angle 2. I mean, it doesn't really matter. But 10x minus 8, that's angle 1's measure, plus 13x minus 42 is equal to 180 degrees. So now we combine our like terms. I've got my x terms, my constants, and we get that 13 plus 10 is 23. So we get 23x, and negative 8 plus negative 4 is negative 12. And that's still equal to 180 degrees. Now I'm going to use inverse operations. I'll stick with black. All right, I'm going to add my constant 12 to both sides of the equation. And 23x is equal to 192. And finally, we divide both sides by 23 to get that x is equal to, oops, that's 13x minus 42, not 13x minus 4. So that's going to change things up a bit for us. Let's slide that over. All right, so we got 13x minus 42, which will give us 50 in this step. My bad. So we would want to add 50 to both sides. And 180 plus 50 is 230. Alright, we still want to divide by 23 as our last step, and we get that x is equal to 10. So we solved for x. Now let's find z. And for this one, there are two routes to solve for z. Knowing that x is 10, I can plug that into this equation and figure out what this angle measure is, and it's supplementary to z. So sorry, I called that an equation, that expression. And plug x into that expression and then solve for z, okay, because these two angles are supplementary. All right, so we end up solving an equation like we did well here actually, or I can plug x into the other equation, 13x minus 42, and for me that makes a lot more sense because once I find this angle measure, it's vertical to angle z, or z degrees, so they're equal in measure. So by finding 13x minus 42 when x is 10, I'm finding z. In other words, I can go ahead and say that z is equal to 13x minus 42. And so z is equal to 130 minus 42. And z is equal to 88 degrees. Okay. So, two very simple relationships that occur, angle relationships that occur when two lines intersect. Linear pairs, vertical angles, and we'll use those, like I said, throughout chapter 7, the supplementary angles and congruent angles.